Imagine you're on a journey to the largest planet in our solar system. As your spacecraft approaches, you see the majestic, swirling bands of orange, white, and red. You prepare for a landing, looking for a solid horizon, a place to plant a flag. But as you descend through the ammonia clouds, you realize something terrifying. There is no ground. You aren't landing, you are falling. You are plummeting into a world so vast that it could swallow 1,000 Earths like a hollow shell. As you sink deeper, the sunlight fades to pitch black, and the weight of the atmosphere begins to climb. If you don't turn back, the sheer intensity of the environment will crush, melt, and eventually vaporize your ship. This is Jupiter, the king of planets. For centuries, we have only seen its face, a tapestry of storms and stripes. But thanks to NASA's Juno mission and cutting-edge simulations, we're finally peeling back those clouds to reveal a chaotic, metallic, and fuzzy interior that defies everything we thought we knew. Today, we're going where no human or machine can survive, into the hidden depths of Jupiter.
If you enjoy deep-dive science documentaries like this, focused on real data, real mysteries, and the edges of human knowledge, consider subscribing. New videos explore the universe where certainty ends and discovery begins. And let us know in the comments what you think. Thanks for watching.
Why are scientists so obsessed with what's happening thousands of miles beneath Jupiter's clouds? It's because Jupiter isn't just a planet, it's a cosmic time capsule. Formed roughly 4.6 billion years ago, Jupiter is the oldest planet in our solar system. When the Sun was born, it left behind a disk of dust and gas. Jupiter was the first to eat, scooping up more than twice the mass of all the other planets, moons, and asteroids combined. In fact, Jupiter is made of the same ingredients as a star, mostly hydrogen and helium, but it simply didn't grow massive enough to ignite. By studying its deep structure, we're essentially looking at the original recipe of our solar system. If we can understand how Jupiter formed and where it came from, we can solve the mystery of how Earth and the other planets were born. But there's a problem. Jupiter's atmosphere is a chemical maze. Molecules travel between the scorching heat of the deep interior and the freezing upper regions, changing states and rearranging themselves in thousands of different chemical reactions. Until recently, the dense clouds of water and ammonia were a brick wall for our instruments. In 2003, the Galileo probe tried to take a peek, but it lost contact with Earth as it plunged into the crushing depths. It wasn't until the Juno spacecraft arrived and began measuring Jupiter's gravity and magnetic fields that we finally started to see the skeleton beneath the skin. The most iconic feature of Jupiter is the Great Red Spot, a crimson hurricane twice as wide as Earth that has been observed for over 300 years. But for a long time, we didn't know if this was just a thin sticker on the surface or a deep-rooted monster. Juno's flybys changed the game. By using gravity sensors, scientists discovered that the Great Red Spot isn't just surface level. It extends down to a depth of about 300 miles, 500 kilometers. This is a massive discovery because it means the storm reaches far below the level where sunlight can warm the atmosphere and even below the point where water condenses into clouds. But it's not just the red spot. Jupiter's atmosphere is a battlefield. The planet's incredibly fast rotation, a full day lasts only 9.9 hours, whips the atmosphere into powerful jet streams. These winds, which can reach 335 miles per hour, create the famous belts and zones we see from Earth. Before Juno, we didn't know how deep these winds went. Now we know. These jet streams penetrate roughly 2,000 miles, 2,500 kilometers, into the planet. Deeper still, the atmosphere undergoes a strange transition. Around 40 miles beneath the water clouds, the way the atmosphere glows in microwave light actually flips, revealing an interior structure that behaves remarkably like the Earth's oceans.
As we go even deeper, past the point where any spacecraft could survive, the physics of Jupiter gets truly alien. Because the pressure is so extreme, the hydrogen gas is squeezed until it turns into a liquid. This creates the largest ocean in the solar system, but it isn't made of water, it's an ocean of liquid hydrogen. Halfway to the center, the pressure becomes so intense that electrons are actually squeezed off the hydrogen atoms. This turns the liquid into a substance called liquid metallic hydrogen, which conducts electricity just like a metal wire. As Jupiter spins at its dizzying speed, this metallic ocean acts like a giant dynamo, generating a magnetic field 16 to 54 times more powerful than Earth's. This magnetic field is a monster. It creates a bubble in space called the magnetosphere that can extend up to 2 million miles toward the Sun and taper off for 600 million miles behind the planet, reaching as far as the orbit of Saturn. This field traps charged particles and accelerates them to high energies, creating radiation so intense it can fry spacecraft electronics and creates the most spectacular auroras in the solar system at Jupiter's poles. For decades, textbooks taught us that Jupiter had a small, solid core made of rock and ice, about the size of Earth, which acted as the seed for the planet's growth. But when Juno measured Jupiter's gravity field with extreme precision, the data didn't match the solid core theory. Instead, scientists found something much stranger, a fuzzy or dilute core. Rather than a solid ball of rock, Jupiter's center appears to be a partially dissolved mix of heavier elements, ice and rock, that is blended with the metallic hydrogen above it. There is no clear line where the core ends and the mantle begins. This fuzzy core is much larger than expected and suggests that something violent might have happened in Jupiter's early history, perhaps a massive collision with another protoplanet that stirred up its interior. This discovery is forcing astronomers to rewrite the history of how gas giants are born. If the core is dilute, it means the building blocks of the planet were mixed much more thoroughly than we ever imagined. One of the heated debates in planetary science has been about one single element, oxygen. Why oxygen? Because on Jupiter, most of the oxygen is locked away in water. If we know how much water is inside Jupiter, we can figure out where it was born. In January 2026, a groundbreaking study from the University of Chicago and NASA's Jet Propulsion Laboratory used new chemical and hydrodynamic models to finally provide an answer. The study found that Jupiter likely contains 1.5 times more oxygen than the Sun. This is a supersolar abundance, and it's a huge clue. You see, water ice is much easier for a growing planet to scoop up than water vapor. Because Jupiter has so much oxygen, it suggests the planet might not have been born where it is now. Instead, it likely formed further out in the cold reaches of the solar system, where water was frozen into ice before migrating inward to its current position, 5.2 astronomical units from the Sun.
This study also revealed that Jupiter's atmosphere is much lazier than we thought. While we see violent storms on the surface, the vertical movement of gases in the deep atmosphere is actually 35 to 40 times slower than standard models predicted. A single molecule might take several weeks to move through an atmospheric layer rather than just a few hours. Jupiter is a world of extremes. It has the shortest day, the strongest magnetic field, the deepest storms, and a fuzzy heart that defies explanation. Every time we think we have solved the king of planets, it reveals another layer of mystery. We've learned that its great red spot is 300 miles deep, its winds go down 2,000 miles, and its oxygen levels tell a story of a planet that wandered across the solar system billions of years ago. But as complex as the planet is, it might be even more hostile to life than we thought, with pressures and temperatures far too extreme for any known organism to adapt. However, the story of Jupiter doesn't end with the planet itself. While Jupiter's interior is a crushing wasteland, its 95 moons are a completely different story. One of them, Europa, is covered in a shell of ice, but hidden beneath that frozen crust is a vast liquid water ocean that could contain all the ingredients for life. Could there be something swimming in the dark oceans of a moon orbiting this gas giant? NASA's Europa Clipper mission is already on its way to find out. But to understand the secrets of the ice moon, you'll have to watch our next deep dive into the search for life beyond Earth. Don't forget to like, subscribe, and hit the bell so you don't miss our next voyage into the unknown.